Hello and welcome to this special deep dive report. The date is December 23rd, 2025. As the world wakes up to another cold winter day, the space comet 3I Atlas, only the third visitor found from outside our solar system, is slowly moving further into the dark void. It is leaving scientists and thinkers alike wondering about its strange journey. Tonight we're going to skip the headlines and look right at the facts to see exactly where this thing is, what it is doing, and why it matters so much to our view of the world. Right now, at this very second, on December 23rd, the comet is sitting in the group of stars called Leo. If you were to look at a star map, you would find it at the spot of right ascension, 10 hours, 29 minutes, 45 seconds, and declination, plus 8 degrees, 26 minutes, 16 seconds. For people in most of the northern half of Earth, it stays below the horizon until the late night rise times. It is a quiet traveler moving against the stars of the Lion, a shape that has watched over humans for thousands of years. But unlike the stars that make up that known shape, 3I Atlas is a passing ghost here for a short moment in space-time before leaving forever. Just 4 days ago, on December 19th, 2025, 3I Atlas made its closest pass to Earth. It went by at a distance of about 269 million km. To help you understand, that is about 1.8 times the distance between the Earth and the Sun. It was not a close call like in a movie, but in space terms, for an object that traveled for years to get here, it was a close visit. As many people now think about the end of the year and holiday gifts from family and friends, some have joked if this space visitor might bring an interstellar gift of its own. Let's look closer at the facts about this gift. The timing is nice, truly a visitor from the stars coming just before the holidays. But science deals in math and physical laws, not poems. The path of 3I Atlas has been watched by every big telescope on Earth and in space. We have tracked its move with a focus that would have been impossible just 10 years ago. And what we see is an object that does not care about our calendar. It is following a wide path, a curve so open that it proves the comet will never come back. It is a one-way trip through the solar system. If you are liking this deep look into how our universe works, please think about joining the channel. We are here to bring you the science behind the news, explaining the hard truth of space travel without the loud talk. Your help helps us keep these deep looks going. Now, back to the comet. The question on everyone's mind, pushed by social media talk and the natural human want for a link with the stars, is simple. Is it leaving anything behind? When a comet passes through the inner solar system, it gets warm. The ices that have been frozen for ages begin to melt, turning straight from solid to gas. This change lets out dust and rocks, making the pretty tails we see with comets. 3I Atlas is no different. It is dropping stuff. But where is that stuff going? Here is the main point that often gets lost in the fun. The moves of space objects are ruled by their huge speed and the exact way they come in. 3I Atlas came in fast and it is leaving fast. Its speed compared to the sun is amazing. This high speed means that any stuff it drops keeps that same push. It is not like dropping a piece of trash out of a car window where it falls to the side. It is more like shooting a ball from a moving jet. The bits travel with the main body. However, the link is not just about gravity. We have to think about the solar wind, the stream of tiny bits flowing out from the sun, and the push of sunlight itself. These forces work on the dust and gas let out by the comet. For a normal comet like Hauy or Neo-Eyes, we know these links very well. We can guess meteor showers years early because the trash trails are left in said paths that Earth hits. But 3I Atlas is different. It is not in a closed path. Its trail does not make a closed loop that we can cross year after year. It is a single line across the solar system. So what does this really mean for the space gift idea? It means that for Earth to get any stuff from 3I Atlas, we would have to be in exactly the right spot at the right time to catch the path of a ship that is moving faster than anything we have ever made. The way the visit worked on December 19th put us 269 million km away. That is a huge ocean of nothing. For stuff to cross that gap, it would need to be kicked from the comet with huge power, or be moved by forces that push it right at us. This goes against what we used to think about how comet tails act in these fast visits. Early ideas hinted that maybe the solar wind could spread the tail out wide enough to touch the Earth. But as we fix our ideas with facts from the James Webb Space Telescope and other tools, the picture gets clear. The stream of bits is more tight, more ruled by the science of the comet's high speed. The gift, it seems, is staying wrapped up in the comet's own pull and speed power. In more clear terms, a question comes up: could any stuff dropped by 3I Atlas really reach Earth? The worry is not totally silly. We know that comets are like chemical shops. They carry the building blocks of solar systems, water, gas, and more complex living bits. If 3I Atlas formed around a different star, its chemical mix is a direct piece of that alien world. Getting a piece of that stuff would be the science win of the century. It would be like having a piece of a far planet sent to our front door. But there is a darker side to this talk. Light tests have shown that the gas cloud around 3I Atlas has cyanide and hydrogen cyanide. The last one is a very deadly mix. Used in the past as a gas weapon during World War I, the mere talk of cyanide starts a deep fear. It moves the story from a space gift to a space poison. At first look, the idea of such stuff moving toward Earth might sound scary. It brings up scenes from sci-fi where passing space rock brings a sickness or a poison cloud. We need to split the chemical truth from the fear. Yes, cyanide is there. It is actually quite common in comets. We see it in comets from our own outer cloud all the time. It is a simple bit, carbon and nitrogen, easy to make in the cold deep of space. Its being in 3I Atlas proves that the science of other star systems is not totally unlike our own. But having a poison in a comet, 269 million km away, is very different from that poison being in our air. To understand the risk, or lack of it, we have to look at the thickness of space. Space is, for a very good guess, empty. A cloud of gas let out by a comet grows fast. As it grows, it becomes very spread out. By the time any gas from 3I Atlas could maybe cross the gap to Earth, the tiny bits would be so far apart that they would be hidden. It would not be a cloud, it would be a space slightly less empty than normal. But we cannot just wave our hands and say space is big. We need to do the math. We need to look at the mass loss rate, how much stuff the comet is really throwing off, and the forces working on that stuff. This is where the story gets fun and where the science gives a final answer that cuts through the fear. The link between the solar wind and the comet bits is the key. As we get ready to look at the exact science of this poison cloud story in the next part, keep in mind the size of what we are talking about. We are tracking a mountain of ice and rock rolling through the dark, dropping a thin veil of gas while our planet stays safe millions of kilometers away. The universe is rough and toxic in many spots, but it is also ruled by laws that keep us away from most of those dangers. In the next part, we will strictly check the poison cloud idea. We will use the newest facts from the James Webb Space Telescope to figure out exactly how far that cyanide gas goes before it is blown away by the sun. We will see why the solar wind is our best shield and why the science of the solar system makes the move of gas from 3I Atlas to Earth not just unlikely, but physically impossible. Stay with us as we break the myth and show the hidden forces that guard our world. Welcome back. In the last part, we set the scene of 3I Atlas's trip through Leo and the public interest and slight fear around its closest pass. On December 19th, we spoke on the find of cyanide and hydrogen cyanide in the comet's head, a find that has fed some worry about a space load moving toward Earth. Now, we are going to break that fear, not with kind words, but with hard science. Let's look closer at the facts about this chemical mix. Light tests have indeed proved the being of cyanogen CN and hydrogen cyanide HCN. These are simple living bits made of carbon and nitrogen. In the world of a lab on Earth, hydrogen cyanide is deadly. It stops the body's power to use air. It is a scary thing, but the setting is everything. In the world of a comet, it is a normal building block. We saw it in Comet Halley. We saw it in Comet Hale-Bopp. It is a mark of the old soup from which planet systems form. The fear is that this poison cloud could break from the comet and move across the 269 million kilometers between us, finally falling into our air. To see why this cannot happen, we have to look at the world the comet is moving through. It is not moving through still air. It is moving through the sun's area, the home of the sun. The sun is always sending out a stream of tiny bits, protons and electrons, known as the solar wind. This wind blows out at speeds from 300 to 800 kilometers. When gas bits are let out from the heart of the atlas, they are first neutral, but very fast they are changed. Bright light from the sun knocks bits off these pieces, giving them an electric charge. Once they are charged, they are no longer free to move. They become tied to the magnetic lines carried by the solar wind. This is the main point. The second the gas becomes changed, it is caught by the solar wind and carried straight out away from the sun. Tests of the comet's mass loss rate, including those found by the James Webb Space Telescope, let us figure out the stopping distance of these gas bits. This is the distance a gas bit can travel from the comet heart before it is fully caught by the solar wind. The facts show that the gas sent by 3I Atlas is caught within just a few million kilometers of the comet itself. So what does this really mean? It means the comet is wrapped in a bubble of its own gas that is quite small in space terms. Past that bubble, the gas is pulled away and sped out of the solar system, moving away from the sun and away from Earth. The stopping distance is more than 10 times smaller than the 55 million kilometers between 3I Atlas's path and the circle made by Earth's path around the sun. Let's see this. Imagine the comet is a boat moving across a fast river. The gas it lets out is like dye dropped into the water. The dye might spread out a little bit around the boat, but the flow of the river, the solar wind, quickly grabs it and carries it away. Earth is on the other side of the river, far away, or next to the flow. There is no physical way for the dye to swim across the flow and reach the other side. The flow of the solar wind is the main force, and it makes a hard wall that the gas cannot cross. This goes against what we used to think might be possible if the solar wind were weak or the comet's output were much higher. If 3I Atlas were blowing up with the power of a supervolcano, maybe it could beat the local solar wind. But the facts from Webb show a small steady gas flow. It is active, yes, but it is not a monster. The science is strong. None of this gas ever comes close to our planet. Before we move on to the question of solid bits, I want to hear from you. We often hear about the dangers of space, rocks, rays, solar flares. Does the idea of space germs worry you, or do you trust the huge gaps of space to keep us safe? Leave a note below with your thoughts. I read through them to see what parts of these deep looks matter to you. Now, having dealt with the gas, we must talk about the solid stuff, dust. Comets are often called dirty snowballs, and as the ice melts, the dirt is let out. Dust acts like gas, but with a change. It is not moved by the magnetic field of the solar wind in the same way, but it is moved by light. Sunlight push is a force we rarely feel in daily life, but in space, it is strong. Bits of light from the sun hit dust bits and push them. For very small bits, those smaller than a tiny dot like smoke, this push is huge. It blows them out of the solar system faster than gravity can pull them in. These tiny bits are fast kicked out. They form the straight blue gas tails and the spread dust tails we see in photos. Larger bits, grain size or more, are less moved by sunlight or the solar wind. They have enough mass that their speed carries them along the comet's path. This is where the shape becomes our shield. Remember, 3I Atlas is on a wide path. It is not in a path that crosses Earth's way. It is passing above the flat part of the solar system, the ecliptic, and diving down or cutting through at a sharp angle. Even if these larger bits were to hit Earth's path, we have a second line of guard. Our air. A small-sized bit hitting the air at comet speeds, tens of kilometers per second, has a lot of move energy, but it is small. It would burn up fast. We see this every night as meteors or shooting stars. These are usually bits of sand from comets that passed by hundreds of years ago. If 3i Atlas dropped small dust that hit us, it would lead to a nice meteor show, nothing more. It would be a light show, not a disaster. To be a threat, the bits would need to be big. We are talking about rock-sized things, boulders really. These would be large enough to maybe lift through the air, or at least cause a big air blast like the Russia event in 2013. But do comets let out boulders? And if they do, what are the chances of one hitting us? This brings us to the world of math. We can guess the total mass lost by the comet and the size spread of the bits. Most of the mass is in fine dust. The part of mass in large boulders is tiny. Given the measured mass loss rate of 3i Atlas, we can figure out the top limit on how many large bits could have been let out. The numbers are good. Fewer than 1 million such large bits could have been let out in recent months. That sounds like a lot, but they are spread across a huge space of nothing. A space measured in big units starting from distances more than twice the Earth's sun gap. Even the closest of these guessed bits would never come near Earth closer than 10 Earth widths. 10 Earth widths is about 64,000 kilometers. That is a safe miss, and that is the closest guessed bit in a worst-case spread. The chance of hit is basically zero. It is not zero, because in space, nothing is ever zero. But it is as close to zero as you can get without using the word impossible. So we have ruled out the poison gas, we have ruled out the dust, we have ruled out the boulders. Science and math have built a fort around Earth, guarding us from the physical bits of 3i Atlas. But all of these ideas of course rest on one key guess, that the let-out stuff acts as lazy bits. We are guessing it is just dumb rock and ice following Newton's laws and the push of sunlight. But what if it isn't? What if the stuff or the comet itself is able to move? That point brings us back to the more guess side of the talk. It opens the door to an idea that has been debated since the coming of the first space visitor, Oumuamua. Could 3i Atlas be something else, totally? In the next part, we will leave the easy truth of solar wind science and enter the talk that has split the science group. We will look at the points for being made, the odd path shifts, and why some experts refuse to close the book on the idea that we are being watched. We have shown that the gas and dust from 3i Atlas pose no threat to Earth. The solar wind acts as a broom, brushing away the toxic cyanide, and the huge gaps combined with path math ensure that any solid bits miss us by a safe gap. We use the term basically zero to describe the risk. But let's dig deeper into that term. In science, small is a strong word, but it needs hard proof. We need to see the hit math, the exact math that lets us sleep well while a mountain-sized thing flies through our area. As we showed, the main guard against large bits is the huge size of space. It is hard for the human mind to grasp just how empty space is. We see maps of the solar system with planets and comets drawn as large balls, making it look full. In truth, if the Earth were the size of a pea, the Sun would be a beach ball over 100 meters away, and 3i Atlas would be a grain of salt passing kilometers in the distance. The target Earth is tiny compared to the void. Let's look closer at the facts about the mass loss rate, which is the thing that drives this whole math. The James Webb Space Telescope and other tools measure the light of the comet and the thickness of its tail to guess how much mass it is dropping per second. For 3 Atlas, this rate is normal for a standard comet body. It is not falling apart. It is not dropping its skin in huge bits. It is melting slowly. If we take the total mass lost over the months it has been in the inner solar system and model it as a cloud of bits, we have to spread that mass across the size range. The huge majority of bits are tiny. The number of bits drops fast as the size grows. For every billion dust grains, there might be one pebble. For every billion pebbles, one boulder. When we run the test, guessing the bits are kicked out in all ways or even mostly toward the sun, which is normal for comets, the resulting cloud is thin. We figured that fewer than 1 million bits larger than a meter could have been let out. Now take those 1 million bits and spread them over a ball with a width of 200 million km. The thickness of bits becomes very small. Here is the main point. The kick speed. When a piece of rock breaks off a comet, it doesn't just stay there. It is pushed away by the growing gas, but this push is soft. The kick speed is usually only a few meters per second compared to the comet. This means the bits stay very close to the comet's own path. It doesn't fan out into a wide blast that covers the whole sky. it stays a tight line. Since 3I Atlas's path does not hit Earth's path, it misses us by 55 million kilometers at the closest point of the path's line. The bit stream also misses us by about that same gap. A few meters per second of drift over a few months only adds up to a few thousand km of shift. That is nowhere near enough to cross the 55 million km gap. So what does this really mean? It means that for a piece of 3I Atlas to hit Earth, it would need to have been kicked with a speed of kilometers, shaken, aimed right at us months ago. There's no natural way for a comet to shoot a rock at Earth, like a cannon. Natural gas flow is a soft push, not a blast. This goes against what we used to think might be a risk factor, the idea of braking events. Sometimes comets do break apart. Comet. Atlas C219Y4. A different thing totally fell apart famously. If 3I Atlas were to break fully, the bits cloud would grow, but even then, the middle of mass of that cloud would follow the first path. The growth would have to be very violent to reach Earth, and we have seen no signs of breaking. The heart stays whole. The heart of the comet is beating steady. However, we must be full. We spoke of meter-scale sizes. Why is that the line? Things smaller than a meter burn up. Things larger than a meter can live to the ground or blast in the low air. The Tunguska event in 1908 was likely caused by a thing 50 to 60 mists wide. The Russia meteor was about 20 mils. 3I Atlas itself is likely only a few hundred meters to a kilometer wide. It simply doesn't have the mass to make a fleet of large hit things. It would have to drop a big part of its total mass in huge bits to make even one threat. And we would see that happening. The comet would dim or change shape a lot. It hasn't. The math is very much on our side. The chance of a hit from a bit of 3I Atlas is lower than the chance of being hit by a random rock that we haven't found yet. It is a risk that feeds into the background noise of space dangers. But there is a lasting question in the back of the mind. We are modeling this thing as a dirty snowball, a mix of ice and rock that follows the laws of heat and gravity. We guess the mass loss is driven by the sun warming the ice. We guess the path is set only by the sun's pull and the slight jet effect of the gas flow. All of these ideas, of course, rest on one key guess, that the let-out stuff acts as lazy bits, unable to move via tech power. That point brings us back to the more guess side of the talk. What if the gas flow isn't gas flow? What if the path isn't just gravity? Right now, 3I Atlas is about 269. 9 million kilometers, 1.884 AU from Earth. And that gap is slowly growing. It is racing away. But as we track it, we look for odd things. We look for things that don't fit the dirty snowball model. And there are experts who say that we shouldn't be so quick to ignore the odd things we do see. New looks from the Comet database, updated as recently as December 21st, show that the thing stays active. It has a head, 2 units wide and a tail going 7.8 units. These are clear signs of life. But is it natural life? In the next part, we are going to look at the main idea. We will look at the work of Harvard astrophysicist Avi Loeb and others who hint that things like 3I Atlas might not be rocks at all. We will check the non-gravity speed, the tiny push that comets feel, and ask if it could be the mark of an engine. We will look at the sharp shape of its coming and ask, was this a random pass or a set scan? The line between sci-fi and new science is often set by facts, and the facts on space objects are odd enough to keep that line fuzzy. Join us as we step into the unknown. We have done the math on hit chances and found them good. We have checked the chemical mix and found it toxic, but far. By all normal tests, 3I Atlas is a natural thing, a piece of ice and dust kicked from a dying solar system ages ago, passing through ours by pure luck. But science grows on testing norms, and when it comes to space visitors, the norm is still being made. We have only seen 3 such things in history. A group of 3 is hardly enough to set a normal. This brings us to the alien tool talk. It is a talk that moved from the edges to the main part with the coming of Oumuamua in 2017, and it has started again with 3I Atlas. The heart of the talk rests on the lazy bits guess. We guess the thing is dead, rolling, and acting blindly to the sun. But what if it isn't? Harvard astrophysicist Avi Loeb, well known for his bold ideas about alien tech, has hinted that we need to keep an open mind. He says that if we only look for rocks, we will only find rocks. Must think of the chance that 3I Atlas's sharp wide path showing a high number of 6, 14 could be a sign of something more. Let's look closer at the facts about this number. In path science, a number of 0 is a perfect circle. Between 0 and 1 is an oval like Earth or Halley's Comet. Exactly 1 is a curve. Anything more than 1 is a wide path, an open way that never returns. Oumuamua had a number of about 1. 2. Comet. Boris, the second visitor, had about 3. 3. 3. 3. I Atlas has a number of 6. 3. This is extreme. It means the thing is moving very fast compared to the sun. It is punching through the solar system with huge power. Avi Loeb hints that this high speed and the thing's clear lack of care for Earth during its pass could in theory be like a made probe. In Avi Loeb's words, this could be a kind of message in a bottle, passing through our system without slowing down or turning. The idea is that a dead probe or maybe a sign in a huge space web wouldn't have to stop to say hi. It would just drift, carrying its facts or its message, moved by the speed energy of its start millions of years ago. This goes against what we used to think about first contact. We always thought of ships landing on the White House grass or radio signs sending prime numbers. We didn't think of quiet, dark shapes rushing past the sun and ignoring us. But if the galaxy is billions of years old, it could be full with such trash. Tech trash, rather than active scouts. Here is the main point that feeds the talk. The non-gravity speed. Comets are pushed by the jet effect of gas flow. We see this with 3I Atlas. It is turning slightly from a pure gravity-only way. Main experts say this is from the melting of ice we talked about before. The gas shoots out one way, the comet moves the other. It fits the model. But fans of the made idea ask, is the gas flow enough to explain the push, or is there an extra speed? With Oumuamua, there was no seen tail, yet it sped up. That was the big clue for Avi Loeb. A push without a gas means a solar sail or some other way. With 3I Atlas, we do see a tail. We see the gas. This makes the natural answer much stronger. The seen head and tail found by COBS and big tools give away for the move. Yet talk stays. Some have pointed to small shifts in tail life found by ESA's XMM Newton on December 3rd as possible. Odd things. The X-ray signs from comets are usually caused by the solar wind hitting the comet's air. Shifts in this sign can tell us about the thickness and mix of that air. The shifts could be seen as spitting or timed life. So what does this really mean? Main experts stay not sure. They say these effects are from natural ice volcanoes, jets of gas blowing from under the crust as the comet turns, or uneven gas flow, where one side of the comet is more active than the other. Links with the solar wind can also be rough and messy, making complex shapes that look like odd things but are just fluid moves in space. Searches for tech signs by groups such as Breakthrough Listen have so far shown no proof of made signs. We have aimed radio tools at 3I Atlas, listening for the clear, narrow signs that would show a sender. We have listened for radar pings. We have heard only the noise of the universe, silence. But, as Avi Loeb often says, lack of proof is not proof of lack. A dead probe wouldn't be sending. A lazy sensor wouldn't be beeping. The silence doesn't prove it's a rock. It just proves it's not a radio station. The talk is good. It forces us to fix our models. It forces us to look closer. If we ignore every odd thing as just a weird rock, we risk missing the most important find in human history. But if we yell alien at every shadow, we lose science trust. The balance is found in the facts. And right now, the facts lean hard toward natural. The 3I Atlas looks like a comet, acts like a comet, and smells like a comet. But it is a comet from somewhere else, and that alone is big. It carries the history of a different star. It is a messenger, even if it is a dumb, frozen one. As we move to our last part, we must accept the truth of the case. The window of chance is closing. 3I Atlas is leaving. It is fading. The chance to study it up close has passed. We are left with the facts we have gathered and the questions that stay. In the next part, we will look at the quiet goodbye. We will track the comet's last path as it heads back into the dark. We will talk about what we have learned, what we missed, and what this visit teaches us about our spot in the galaxy. The visitor is leaving the room, but the sounds of its pass will be studied for years to come. The talk over Maid starts may never be fully settled to everyone's liking, but the physical truth of 3I Atlas is not up for talk. It is a physical thing following the laws of move, and it is leaving. We are now seeing the quiet goodbye of our space guest. The fun of the closest pass is behind us. The news is starting to fade, but for the experts, the work is far from over. For now, 3I Atlas keeps its quiet pass through Leo, fading steady as it goes back into space. It is a ghost moving through the lion's hair. Guesses show it will grow dimmer over the next weeks. By early 2026, its gap from Earth will top out, and it will become a faint spot seen only by the most strong eyes on and off the planet. Finally, it will vanish past the edges of the outer cloud, that huge shell of icy trash that wraps our solar system, never to return. Let's look closer at the facts from the last part of this trip. Big tools are still paying close focus. The Hubble Space Telescope last saw 3I Atlas on November 30th, taking high-detail views of the heart and head. A wider NASA multitask group, including facts from Europa Clipper, which is on its own trip to Jupiter, and MAVEN at Mars, has proved ongoing gas flow of hydrogen and dust. This multi-point view is key. By seeing the comet from different spots from Earth, from Mars, and from the deep space path of Clipper, we can build a 3D model of the flow. We can see the shape of the tail, not just as a flat view on the sky, but as a solid shape. This backs up the picture of a fast-changing thing rather than a sleeping relic. It is alive in the rock sense, acting to the fading heat of the sun. New looks from the Comet database COBS show the light level falling. It is now at 1529. That is far past naked eyesight. You need a large tool to see it. As it moves away, the math law of light takes its cost. It gets less sunlight to show, and it is further away from us seeing the light. It will fade into the blackness fast. So what does this really mean for the story of 3I Atlas? It means we have a small set of facts. We didn't have a ship ready to catch it. We couldn't start a probe to land on it or fly next to it and grab a piece. We had to watch from a gap. This shows a hole in our planet guard and search powers. We are getting better at finding these things, but we are not yet fast enough to catch them. However, the facts we did get are a gold mine. The light of cyanide and hydrogen cyanide, the dust-making rates, the light curves. These are puzzle pieces. They tell us about the science of the star system where 3I Atlas was born. Was it a star like our sun, a red dwarf, a twin system? The tiny parts in the gas might hold the answer. We'll be checking these facts for decades. Whether it is just a space drifter, a frozen relic from a far star system, or something more odd, 3I Atlas works as a strong sign of how much we have yet to learn. It tells us that our solar system is not a closed box. We are open. We are part of a galaxy system where stuff is traded between stars. With no new blasts told today, the comet stays a fun puzzle. It didn't break up. It didn't call us. It just passed through. It tells humans to keep watching the skies and asking hard questions. It dares us to be ready for the next one, because there will be a next one. The math says that space objects are passing through the solar system all the time. We just usually miss them. Now that we know how to look, we will find more. The stars, after all, may yet say more. 3I Atlas was a whisper we barely heard. The next one might be a shout. If you found this deep look helpful, if you like the work to split fact from fiction and fear from science, please leave a like on this video. It helps the computer share this science view with more people. And if you haven't yet, join and hit the bell so you don't miss our next look. We are watching the skies, we are doing the math, and we will be here to tell you what it all means. Until next time, keep looking up.